No sound.
Hello? Can you guys hear me? Oh yeah, I can hear myself. Cool, we can get started. All right, well thank you everybody for coming back. Those of you that don't know me, my name is Michael Akopov. Kevin and I run this thing. So a couple of announcements, and then I'm actually going to present today to you about AWS. And so, as I pointed out before, we have pretty much a presence everywhere, it seems like. We have a website, Twitter, we're on YouTube, we are on Twitch as well. We're live streaming to Twitch right now, and then the video will be up on YouTube if you want to go back later and watch the episodes. It'll be on the website, I'll link to it. The handle for all of that is full stack TC, pretty much for everything, GitHub included. So, also wanted to thank our sponsor, Wildlands, for helping us set this up. Fuse for the facility, and Wheelhouse for providing us with drinks. I promised that I would include a quote with pretty much every meetup, like an inspirational quote. So this time I decided to say, to teach is to learn twice over. For some reason that resonated with me when I was making that slide. But that has been kind of the basis of this meetup, is to grow in teaching others and helping others. All right, so next month's meetup. So I kind of started a tradition where every December we kind of take a break from our traditional scheduled meetup and we go do something fun. And so last year we toured LIGO. We went out there, out in the area, did a tour, then we went out to Dupa's Boomers, I think, for drinks and dinner. And whoever wanted to come came with us. And so this year I think we want to do something similar. Ken Schmidt, who he's not here today, I work with him over at P&L. He has agreed to do a tour of the supercomputer that he works on out there. So we'll do the tour and then we'll figure out a place to go afterwards for drinks and dinner, and you guys can pick. We could do a vote at the end if you guys want. So we kind of have a place scheduled. So that'll be at 4 o'clock on December 5th. It has to be at 4. I was trying to do a little bit later for people that work, but 4 is the latest we can do for badging. And actually, on that note, if you do want to come, I'm going to need your full name, date of birth, and the last 4 of your social so we can get your badge started. And then that way when you arrive there, it'll be pretty much ready to go. And so that's required to get in the facility. That's not something that I'm just asking of you. So I can actually show you a little bit. Where's my mouse? Is it over there? Oh, it's not moving. My computer froze. I was waiting for the music. Sorry, I don't know why it froze up. All right, that's the website. If you go out there, you can actually see the past talks. But here's a quick highlight of the supercomputer. So, kind of the specs here as to the overall compute nodes. There's 1,400 compute nodes, 3.4 petaflops. Well, that's per node. I was talking about the overall RAM is 184,000 gigabytes of RAM, 23,000 Intel cores. So just some of the specs on it. It's a pretty cool system. Like I said, anyway, if you want to go out there to tour, Ken will be giving us a full tour of it. He works on it. He knows all the specs about it. 4 o'clock, it'll be at P&L. For those of you that don't know where that is, so this building is called Discovery Hall. That's where we will meet to go get our badges. And then we will basically walk across the street to get into the facility. If you look on Google, I'm trying to show you guys how to get there. feel free to contact me later with more clear directions. P&L is, if you take G-Way all the way out to the area, pretty much at the end of G-Way, you'll pass WSU, their new wine science facility, which is like, I want to say somewhere over here, I think on this corner. So if you keep going past that, you'll get to Battelle Boulevard. And then on Battelle Boulevard, there's a row of trees right here. There's a row of trees going this way. We'll turn left on Battelle Boulevard. Maybe we could do satellite view. There you go. So the row of trees going this way, this way. There's a field here. And then if you zoom in, you can see. All right, there we go. So there's buildings, like the actual campus starts here on Innovation Boulevard. So this is the actual building where we're going to, no, this one, where we're going to do the tour. But Discovery Hall is actually not on the map. It was built recently. It's right here. So it's on Horn Rapids Road. So there's 240 on the left right here, Stevens Drive. And then there's G-Way over here on this end. And then Innovation Boulevard's in the middle. And there's a building right there that looks like this. So that's where we're going to go meet to do badging, and then we'll walk across the street to go do the actual tour. It'll be at 4 o'clock precisely because the badging office closes shortly after. So anyway, if you do want to do it, come meet me afterwards. I'll take your name, date of birth, the last 4 of your social, and we'll get that going. So, all right. And January 2nd is still open if you would like to give a talk. I realize it's New Year's, but we're still gonna, we met last year and people still showed up, so we're gonna meet again this year and see who shows up. All right, and then the last thing, I'll let Kevin do this one. My mouse. There we go. All right.
All right, so we're trying out this new thing. It's called Game Collab. So the idea of it is we wanted to do a game jam or like a hackathon, but we didn't really want another project that never got worked on again afterwards. So this is a group, kind of a meetup to allow people to come in and start an idea, but also progress on it monthly. So we had our first run of it this month, and we're lined up to do a second event next month. So it's kind of like you come in, you bring $5 for pizza, everybody hangs out for about 4 hours. It's in the evening, 6 to 10, and you just work on stuff. Whether you are a programmer, a musician, a writer, a graphic designer, we see it, and we see all of you as game devs. And that's how you should see yourself too. And we want anybody and everybody with those kind of skills. So designers, creators, you're all welcome. So yeah, come join us. We don't have a date for next month yet, but it'll be probably Friday, Saturday, Sunday, early in December. So
cool. All right. One thing I forgot to mention is, is anybody here a foreign national? Probably not. Okay, that's good. Because if you're foreign national and you want to go on the tour, there's another set of paperwork you have to do. So if you are, just come talk to me, we can do that. But if you're not, that makes things much simpler.
Is that why you were asking if I was Canadian?
That was, yeah.
yeah.
You look suspicious. If you know of anybody that wants to come, invite them, feel free. I just need to know their information. We can get that going. It's open to anybody. So with the one restriction of, if you're a foreign national. All right. Let me clean up my screen. Get to my slides. Cool. Amazon. All right, before we start that, I want to go around, have people introduce themselves. I'll start with me. Like I said, my name is Michael. I'm a software engineer. I work at P&L with Ken, and then do this on the side. I'm going to be talking about AWS today because I've been doing quite a bit of it recently, both at work and kind of on the side as well. And I think it's really cool technology. So before I go into that more, I'll kick it off to you.
Sean Hasselwig, aspiring web developer, currently doing
Kelly Elsis, front-end developer, currently looking for a payload platform and cryptocurrency.
Thomas Maddock, backend software developer, currently Pennsylvania.
John Burnell, aspiring web developer, just moved here from Virginia about 2 weeks ago.
Welcome.
Martin, somewhat of a programmer, electrical engineer, and not a Canadian.
Lance Kendall, hobbyist software developer, and also I really like makerspaces.
I'm Jerry Lynn Cooper. I'm an entrepreneur and an hobbyist, and I just love learning new things.
Chad, software developer, for a while.
Cassandra Lanzola. I'm a front-end developer, and I work at Lifehacks.
I'm Matthew Mason, and I'm a current student at CBC, aspiring to be a software developer.
Cool. Kevin?
Hey, Kevin, I have a hired software developer position.
All right, great. Thank you for doing that. All right, I guess let's get started. So, as I was preparing this presentation, there's a... Is that better? All right, so as I was making this presentation, I was struggling between going in depth in one area, but then I was like, well, that won't make much sense. I need to cover these things as well. And then pretty soon I had this entire outline that was ridiculously long, and to the point where you probably can't even read that in the back. So I'm going to kind of go at a high-level overview of all these technologies, how they can maybe integrate, and I'm not going to do a deep dive into any of them. The most important reason for that is I don't know any one of them very well, right? I know them all to an extent. I'm by no means an expert in AWS. So, take this as a high-level introduction, basically just to what I know about it. Amazon has 150 services they offer in their web platform. So the amount of and there's subcomponents to each of those services as well. So the amount of things you can do is just immense. So I'm not even going to pretend to understand all of it. So the first thing, so I guess does anybody here use Amazon Web Services? One person, 2, 3. All right, 4. Cool. All right, so Amazon, for those of you that don't know, provides a set of compute resources that they cloud providing, right? They're one of the primary cloud providers out there. Majority of the web actually runs on Amazon Web Services. Netflix is all on the AWS, even though AWS competes, or Amazon competes with Netflix, which is kind of funny. The primary model around their data centers, though, is they have these, what they call regions. So each of these dots is a region where they have a data center. And the number inside of that dot is the number of availability zones they have in that region. And availability zone basically means so there is, next slide won't make any more sense to that. Oregon has a data center, and in that data center, or in that region, Oregon, there's 3 separate data centers, which are known as availability zones. They all kind of work together, and you can specify which availability zone you want your resources deployed to, or you can deploy to all 3 at the same time. The reason for that is redundancy. If one data center goes completely offline, you can fail over to the other one pretty seamlessly. Typically, you want to choose the region that's closest to you and your clients, most importantly. A A lot of their services have failovers to other regions, for example, or the replication to other regions. If you have a database service, you're hosting it in the Oregon region, in the West Coast, but you have clients in Europe, you can also have a failover to Frankfurt or a duplication of service over there. So this kind of describes some of their current availability zones. There's Virginia, Ohio. On the West Coast, there's California and Oregon. There's actually 3 in the West Coast. There's the GovCloud as well, which is meant for government cloud hosting. There's a bunch in Asia, and the ones on the right are opening up soon as well. All right, so at a high level, I found this chart online. It's probably hard to read, but this is a very simple overview of a network topology that you could have in Amazon. It's basically just a data center, and you define everything as you go. Typically speaking, if you set up a server in Amazon, it's going to be exposed to the entire world. So normally what you'd want to do is secure that server from everything but what it needs to be exposed to, which is typically like port 80 or port 443 for if you're running a web server. So what you would do is you create something like a VPC. It's this outer box. It's right here. This is like your AWS actual network, I guess. And you create a VPC. And then these boxes here are actually a set of resources that you have in availability zone like B. This is availability zone A. They can talk to each other with specific defined rules and policies. And the VPC here protects your resources on the inside from the internet gateway up there, which is pretty much everybody. And you only expose to the VPC what you want to have access to these resources, therefore kind of limit the exposure there. This is also demonstrating that you can create a VPN connection from your office or your laptop directly to your network here and expose the broader range of services. Amazon provides the ability to VPN to that network. So I'm not a networking expert, but this is just a high-level overview. This is kind of, you need to understand that so that you don't go out there, create a web server today and get hacked tomorrow. You want to make sure you secure what you create out there. All right, so EC2. EC2 is their elastic compute. Basically, it's just servers that they provide. They call them EC2. The nice thing about them is you can spin up servers on demand. You can resize them on demand. You can make a small server with half a gig of RAM and 1 CPU, and you can go all the way up to like, I think 300 gigs of RAM, and I can't remember how many cores you can get. But the point is it's scalable, and you pay by the CPU hour that you use, which is kind of nice because if you shut it down, you're not paying for the server at all. They also have a nice marketplace where there's a set of images out there you can basically grab from the public, people have created, and you can use them. Of course, all the popular like Ubuntu, Amazon's Linux out there, CentOS OS is out there. You can get Windows servers out there. You can get server images that have prepackaged applications, like a Ruby on Rails server you could just deploy out there and it's ready to serve your application, or a Node.js application. There. All right, so these are high-level overviews of example compute instances you can get. So there's a general purpose, the smallest one being the Nano, which is like 2 CPUs, half a gig of RAM, and it builds out at like half a cent an hour, which is roughly $3.80 a month. That's just for the compute, and then you also got to pay for the storage, which is I think a penny a gig on top of that, or maybe 2 pennies a gig. And then the largest general purpose you can get is 96 CPUs and 384 gigs of RAM, which is about $5.50 an hour or $3,900 a month. So it can be pretty costly. So depending on what you need, you definitely want to make sure you don't oversize, otherwise you're going to get a surprising bill at the end of the month with like, how did this happen? Don't try mining for Bitcoin on there or any other cryptocurrency because it's not efficient. People have tried it. You will not make money. You will lose a lot of money. There are other compute resources, like there's Compute Optimize, which gives you basically more CPUs, maybe a little bit less RAM. There's also GPU instances where if you're doing machine learning kind of applications, you can request VMs that have GPUs. I think you can do 8 GPUs right there. So you can have like 41,000 CUDA cores, and that bills out at $24.50 an hour, which is like roughly $17,500 a month for a single VM, which that gets pretty costly. But if you have a need for it for 8 CPUs, you can go out there and spin it up and run your model on there. Storage is another very common use case for Amazon. So the most common storage mechanism is what they call S3. That's kind of like, it's almost like a Google Drive or Dropbox type of setup where you get a web page and you can drag and drop items there, but you can't like directly edit them like you would. It's just basically for storage, right? You put it out there and it's stored. And the really nice thing about S3 is it's easy to use, but it's also very redundant. You get like 11 nines of redundancy there, and it bills out at 2.3 cents a gigabyte per month. So it's not too bad. If you're storing, a couple of gigs of data, you're paying 40 cents, 45 cents a month for it, which is kind of nice. You can also make those things independently available publicly, or just make it private, and you can specify this folder is public, this folder is private. So it's kind of nice for those things. So really quickly, some of these other ones that are less known but also important. EBS is typically what you use in your actual VM that you set up. It's like the hard drive in your computer. Elastic block storage, what they refer to it as. It's 10 cents a gigabyte. If you have a VM out there, you have EBS with it. EFS is like your NFS or Windows file shares, whatever you use. It's kind of the replacement there. It's a distributed file system. It's a 30 cents a gig. And then you have Glacier. So if you have like family photos, or if you're a corporation, you got these documents you want to archive but not keep locally, Glacier is a great alternative for that. It's API access only, but it's super cheap to store. It's like basically tape drives in Amazon somewhere, and it's half a cent or 0.4 cents per gigabyte per month. But there's other fees associated with that, so don't let it fool you. You can only retrieve a certain amount of gigabytes per month without incurring additional costs. If you need to retrieve like terabytes of data, you're going to incur additional costs on top of what it costs to store. So just be aware of that. Snowball, people in here probably will never use it. Snowball is actually pretty cool. If you're a corporation, you got like terabytes or petabytes of data you need to get into Amazon, they'll ship you like this giant briefcase with hard drives in it. And you literally plug it into your rack and you just start offloading data, and you ship it back. Or if you're really giant, they will bring a container, like a semi-container, and they'll drop it off in your front yard, and you plug into it and you start offloading data to it. I think the difference there is like past some petabyte level, you'll go from the briefcase straight to the container. Like a semi will drive to your house or to your corporation, drop it off, you plug it in, and then they come pick it up, take it back to Amazon. They literally just place it on the floor with your data. In some use cases, that is the only way, excuse me, to get your data up there, without waiting for years to upload. Storage gateway is a way to do like a hybrid of on-prem storage and in the cloud storage. Unless you're really into that, you probably will never use it. All right, so databases, that's another area that I think Amazon really excels. So Aurora is kind of my favorite feature. If you use MySQL or Postgres, Amazon created their own, it's not their own version of it, but it uses Postgres or MySQL as a backend engine. They created their own kind of wrapper around it. So Aurora is, as they put it, a distributed fault-tolerant self-healing storage system that auto-scales up to 64 terabytes per database instance. Delivers high performance and availability with up to 15 low latency read replicas, point-in-time recovery, continuous backups to S3, and replication across 3 availability zones. So they basically, you create a database out there, and they do all of that in the back for you, and you just get a database, and it creates like these 15 read replicas all over. And like if you pick Oregon West, it automatically puts your database at all 3 data centers in Oregon. So it's automatic. So I mean, you're basically never going to go down with the service, right? You pay for it, but and also the nice thing about it that I use it at work for a project, and it's nice because when our load goes up, it automatically scales up by itself. That's just built into it. So it might be running at like half a gig of RAM where there's no peak at all or no traffic at all. In fact, Aurora will shut off by itself if there's no traffic to the database. So if nobody is using the database at all, there's no queries for a specified period of time, like 5 minutes or 30 minutes, it'll just shut off and you don't get billed for it. Once there's traffic again, it spins back up, and then it starts serving traffic, and it can scale all the way up to 64 terabytes if you start getting hammered tomorrow, which is really nice. But you do pay for it. So DynamoDB is their replacement for like a NoSQL store if you need to use that. Elasticache, like an in-memory cache like Redis. They have a graph database. I've never used it, called Neptune. RDS is their like raw replacement for MySQL. If you just want a MySQL instance by itself, you go spin up an RDS instance. You could pay like $12 a month and have a database hosted out there with backups and replicas. And then Redshift is kind of their big data warehouse. All right. So anybody here use containers or Docker, anything like that? Okay. I apologize, I have a dry throat today. So Amazon, if you do use it, like Docker or Kubernetes or anything like that, Amazon offers several solutions for that. There's EKS, which is a direct Kubernetes replacement. You pay for your servers that you use. On top of that, you also pay 20 cents an hour because that's what they want to charge you. ECS is their replacement for Kubernetes. You only pay for the resources you use. You don't pay for anything else. And then Fargate, it runs on ECS, but you don't manage any servers in the back end. You tell them, this is my container, go run this for me. It just goes and runs in some server somewhere. You don't really care about it. You can define parameters for it, but it's kind of nice. It's just, you don't have to worry about the underlying infrastructure. You just say, here's my container, go do your thing. All right, so I'm trying to get through these really quick so we can actually do some examples. Beanstalk. So Beanstalk it's like it's a drop in and go type of solution for web apps specifically. So if you have a Java, .NET, PHP, Node.js, Python, Ruby, Go, or a Docker app, you can basically like literally zip up your code, upload it to Beanstalk, deploy an application, and it's just there. Of course, you could do a lot to specifically manage it. You can create, you could point URLs to it. You can create aliases. You can run tasks. You could do backups and all that. But basically, you can just drop in a file and it starts serving it automatically, and it just scales as well. So if you start getting traffic tomorrow, if it's a shopping site, it'll just scale for you. So it's kind of neat. You don't have to worry about anything underneath. You don't have to worry about servers, installing packages, doing updates. You just drop it in and you go. And they don't charge anything extra on top of that, aside from the actual resources you use. So the EC2 fees you saw earlier, that's all you get billed for. And if you're a command line guru, there's a command line option for this as well. If you're in a project, you can say like, there's EB deploy or something like that. And it'll just take your current application on your computer and just deploy it to Beanstalk in your test environment or your dev environment. It's pretty slick. All right, Lambda. So Lambda functions are serverless architecture. Anybody done anything serverless here? Kind of. So it's kind of the new. It's not really new, but it's a newish type thing going on. It's cool. It's good. It serves like this whole microservices architecture, right? To where you can have one thing focusing on one thing, pretty much. The real nice thing about Lambda is you basically kind of like Beanstalk, you give it a set of code. Not entire applications, but just a set of code, and you can just hit that one thing and it'll execute. Whether it's a route to your website that says upload, or I don't know, something like that. Process. If you I don't know, maybe you upload a bunch of images from people for your website, right? And then in the back end, you need to go and process those images to resize them, to make avatars out of them, not full size images. Lambda is a great way to say, here's my code that goes and resizes my images, and then you can go and just start executing, calling the Lambda functions one by one, and then it just does its thing. You don't have to worry about it. It's a way to basically execute code without having to worry about the underlying infrastructure, or to worry about if it completes or when it starts or how to do scheduling, I guess, with it, aside from just calling it. It's also pretty cheap. So the first 1 million requests a month are free, which is kind of incredible, I think. And after that, it's 20 cents per million. So if you think about, I don't do anything per month that requires millions or hundreds of thousands of repetitive transactions. Maybe you do, I don't. So it's pretty cheap. The one caveat to it, it's not a really caveat, it's meant to be this way, it's stateless, so nothing persists. Sorry. If you run something there, the next time it runs, it's gone. So you got to make sure you offload your data to a database, S3 or whatever. That's kind of.
So the Lambda function can touch the SQL backend or something there.
Sorry, yeah, it has access to all of the Amazon resources. It can access anything you specify.
I think that it strikes as almost like a type of concept that it runs this code and then it turns out kind of like a extensive concept that it's kind of like
Yeah. There's no, you don't have to worry about the underlying infrastructure at all. You just kind of give it a set of code to run, and it just runs whenever you.
So you pay for a consistent SQL backend, and then you can shove a bunch of stuff in Lambda that maybe touches that.
Yep.
Cool.
The nice thing is if you can do that, you get 1 million requests a month for free. So you can, like I said, if you have some things like you're resizing images or processing video files, something like that, that's a good way to go, because then you can reduce the actual EC2 instance you need. You don't have to get like a large, you can go to a small, perhaps, reduce your costs there and then leverage this, and it does it on demand. So it's kind of nice. Amazon has a command line interface. If you're a geeky person like that, you can install their command line interface. It's just AWS, that's what it's called, if you like the Yum search or app search. And then real quick, these last slides are one-liners each, so bear with me. IAM is their identity management service they provide. If you have a login, you're going to want to go create an IAM account for doing anything pretty much with it. They discourage the use of like a root account to all of your AWS instances, because if your root account gets compromised, people can go and create large GPU instances and start mining for Bitcoin on your account. So you don't want to do that. And workspaces, it's basically virtual desktops. You can go and set up a Windows system, or you can do Linux, but I think right now it's limited to just Amazon's Linux. But you get a whole desktop environment, and they install a client on your system, and you can basically RDP into it, and you got a whole desktop to use. So if you need that, it's there. CloudFormation is their infrastructure as code, basically. So it's a way to, you create a JSON file or a YAML file. It's really simple, and you define the resources you want to have created. Like, I want one compute instance, I want a database created, I want an S3 bucket, I want policy. You link all these three things together, and then I want you to go and deploy this code to it. And then so basically you take that JSON, you feed it into Amazon, and it goes and does all those things for you, and it deploys your entire infrastructure. And it's not limited to just those things. You can do any of the Amazon services can be put into a CloudFormation file. And so the nice thing is you can reproduce your entire infrastructure with a single file, which is pretty cool. It's actually a pretty good way to manage security.
Do you have an export option for that?
What's that?
You want to export a current environment to a file that action. So since you want to replicate this in another region, export and import, is that an option?
You can see like the code snippet for that specific resource.
Okay, but I was looking for a full set to just put the entire environment elsewhere.
I don't know of anything that, I don't know, it may exist, but I don't know that you could take your current kind of setup and export the whole thing. You can go to the individual resource and see the code output for that, and then integrate that into your CloudFormation script. Perhaps there's some other service out there that will go out there and do it. Because the other limitation, right, is it's region-based too. So if you have resources in different regions, you'll have to know to go out and grab those. And Amazon's dashboard does not do that. So it's nice because you can, again, you can reproduce your entire environment. If you're a corporation with many servers, you have it in a script. If something ever goes down, you can replicate, or you can do it in a test environment, prod environment, stage environment. You can also deploy policies this way. It's kind of nice, right? Test it in dev, it works. You deploy it to prod, you make sure all those policies propagate. All right, so I did a lot of bullet point talking, which is really boring. So here are some high-level examples of what people do with Amazon. So I found this on their Twitter account. So in this particular, this is just the pipeline workflow, right? It goes through these different services and the end result. So in this case, this specific tool that someone built, they took a bunch of audio, they dumped it into S3 for storage. They used Lambda to call store audio, or to store the audio, to transcribe the audio. The audio was podcast episodes that they downloaded. They uploaded it to S3, podcasts that somebody likes. And they usually set up Lambda functions to call these different Amazon services. So I went to store, I went to transcribe the voice to text, to speech. And then they use a service called Amazon Comprehend, which basically is like a machine learning algorithm that does stuff. I don't know. Doesn't matter what it does, but it basically grabs semantic intention with the text, right? And then they were able to basically do a keyword search on all the podcasts and find the podcast that had the content they wanted to listen to. And then they're able to go and listen to that podcast. So, I mean, it was clearly just a hobbyist project, but it was a pretty neat way to take a ton of audio and figure out what you want to listen to, right? This other use case, so this one did a similar thing where it took images and videos that were uploaded to S3, and it basically extracted metadata, and they didn't really describe what that metadata was, but perhaps you could say like there's cats in this video and dogs in this one and humans and how many humans there were. So you can do kind of stuff like that, and that's leveraging some of Amazon's machine learning stuff, which they also provide as a service. I'm not going to touch on it. So that's another workflow. Here's an example of somebody using Amazon's machine learning to recognize people, basically. So there's many different use cases about it. So it kind of just depends on what you're trying to accomplish. So I'm going to switch over to the actual Amazon dashboard. Start going through examples. I'm going to stop. I'm going to mirror my display so I can stare at my display and not back there. All right. Can you guys see that, or is it too small?
You can bump it a little.
Bump it?
Maybe on your goal. Yeah, can you bump your font size?
Yeah, I can.
Oh, yeah, there we go.
Is that better? All right, so I'm already logged into my dashboard because I didn't want you guys to go through the pain of doing my two-factor authentication. But if you go to aws.amazon.com, you basically get this landing page, and you can go and sign up for an account, go through the whole process. I encourage you to set a really strong password, two-factor authentication. So if somebody gets in your account, they can mine for Bitcoin, and then you will pay that bill. Amazon does have a free tier, and oftentimes when you're creating a resource, you'll see that it says free tier eligible, so you can, if you do it right, you can actually run a full web server for a year free. It's kind of cool. All right, so when you go in here, one thing I want to point out that kind of took a little while to get used to for me personally was this top right corner. If you see the drop down here, you choose the region that you want to be in. That's what I talked about in the very beginning. And so I'm in the US West California region, which also encompasses all three availability zones there. Their dashboard is very specific to the zone or the region that you're in. So if you go and look at your compute resources in Oregon, you'll have to literally switch to the other zone, like East Coast, to see those resources. You cannot see resources in all of your zones at the same time. So just wanted to point that out. All right, so when I said Amazon has a lot of services, they really do. If you go on services, and you can really see it, they have anything you can think of. There's machine learning, there's analytics, there's customer engagement. Like you can have a call center set up through Amazon if you have customers calling in, right? You can get a phone number set up, you can answer phone calls, you can do online chats with them to be all professional. So you can pretty much do anything you want. If you're a developer and perhaps you don't have the right development environment or whatever, you can actually deploy something called Cloud9. Anybody ever use that here? Cloud9 is just a, Amazon bought Cloud9. Cloud9 was a company that did online web browser IDE basically. And so you can stand up an instance, VM instance, they deploy with Cloud9, and then you can log in and you can basically do a git clone in there, and it's a full-fledged IDE in the browser. And you could do development that way. You can set rules in there to say, shut off after 5 p.m. because I'm not working, that you're not, you only pay for 9 hours of the day while you're actually doing work or whatever you want to do to save costs, which is kind of nice. So there's services like that, but we can start with IAM, which is right here. If you search in here too, you can find. All right, so this is kind of the user policy stuff. So really quickly, if you go to users, you can see here's my user. When you go create a new user, you basically specify the username, and there's two things you want to note. The person can have programmatic access only, like command line access, or console access. If you do programmatic access, what happens is you get this access key ID, which is like a username, and then you get a secret key, which is a password. Now the secret key is only revealed to you once on the dashboard. So you have to make sure you copy it, write it down somewhere safe, because you will not see it again. That's intentional. So I just want to make sure everybody knows that. All right. Moving on. Let's go to EC2. Let's go do some compute. So this is kind of your dashboard here where you kind of can see, and when I said there's like sub resources inside of each resource, this is what I mean. Like each one of these links does a whole other thing inside of EC2. You can manage snapshots, volumes. I actually just realized that I forgot to mention one thing. So EC2 VMs, like I have one running right here. This is where the full stack website runs. It's just a micro instance. You can go in here and you can see status checks. You can kind of see utilization of your resources. There's CPU, there's disk reads, disk writes, network operations. The one thing you might notice is you cannot see the amount of memory used, like your RAM utilization here, and that's actually intentional. In order to see the actual RAM used, Amazon has to access. They have to have access to your actual VM to be able to grab the RAM used, and they do not access your actual resources. So that's kind of nice because well, they respect your privacy. They don't want to know what's going on inside of your VM. This information they can access from the hypervisor that runs the VM, which is why you can see this information, but not specific things like memory or RAM usage. Also, there's 4 different types or 3 different types of EC2 instances you can get. This one is on demand, which basically means I can resize it as I go, as I want. There are spot instances, which it's like a marketplace where you can specify saying I need this many resources. And if there's a VM that's not being used by someone else, you can actually bid on it and get it for like up to 90% cheaper sometimes than a regular on-demand instance. So it's a good way to go to save some money. There's reserved, which is saying I'm going to pay for a large size VM for the full year, and I'm going to save like 40%. If you know you have an application running, that's like your baseline. It's a good way to go too. And you can also do dedicated host storage where you actually pay for a rack. If you need that for some reason. The caveat to reserved instances is you can't resize them on the fly. You can go bigger and you'll pay the difference for that full year, but you can't just resize whenever you want. So let's go launch a quick instance real quick. That was redundant. Quick instance real quick. So if you go here, you can see different types of VMs you can launch. You can launch a VM that does databases. You can do Windows. You can do Ubuntu. There's special VMs for deep learning, into that sort of thing. with Windows servers. And there's also a marketplace where vendors oftentimes put in their services. So if you want to run F5, but anybody here use Jenkins? Jenkins build node? No? Maybe it's in community. There we go. So Jenkins is a build server for doing continuous integration. Anybody's ever used it? In this case, so oftentimes with these vendors, like with Windows, you'll see there's an additional fee. In this case, it's free, so you're just paying for the actual VM itself. You're not paying for the license. Other things you'll pay for licenses for, and you got to make sure it's like a marketplace where you can go buy these things, but it's built in. So I'm going to go choose it. We're going to deploy a quick Jenkins server. And I'm going to go, so right here it says free tier eligible. If you have any free credits left over, you can select it and go with that. So this is where you basically choose the size of the server you want. And if you keep scrolling, you see these types. This is how they label their servers. And you can see what you're getting here. So if I want 96 cores, 384 gigs of RAM, I could choose this one, but we don't need that. I'm just going to go with a micro instance. Next, you can configure a bunch of details here, how many instances you want. The network that I talked about earlier, you can choose here. Any subnets, auto-assigning IPs, you can choose the role that has access to this. And you can define different monitoring and logging metrics here as well. So the last one is storage. You can define your storage here. 10 gigs seems a little small. Let's go with 100 gigs. You can do tagging if you want, configure security. I'm just going to review and launch. I'm not free tier eligible. It's fine. So this last thing here, when you go create a user in IAM, you have to specify which user has access. And then that user, in this case, I have a key called web server basically that I just use, and that lets me SSH into my boxes. So you can specify which SSH key you want to have access if you're doing SSH connections. Define as much as you want in there, and then at the end it just launches the resource. So your resource is now launching. View instances. So you see right here, we got the new one up. It's still pending, so it's still launching my server. So we can go back to it, let it launch, do its thing. Next, I can show you S3. This is the storage. So S3 has this concept of buckets, which is basically, it's like a containing pod for your data, right? Each of these buckets can have folders within them. So this one in particular I use for hosting some of the images on full stack. So there's Joe's image right there. You can download it. You can also notice that I can make it specifically public, and there's a link to the file itself, or it could be private. So we can go and create a bucket real quick. Test, the name of it. You can copy settings from other buckets. Oh, well, this is a good thing. So buckets have to be unique to the entire data center. You don't get a unique, your bucket name has to be unique with everybody else's. It's not like you can call something test and nobody else called it test. Somebody's obviously called a bucket called test. So I can call this Michael test. Maybe that's probably taken too.
Your user ID, was that unique across Amazon or the data center, and you got in early enough to get Michael?
That can be unique. Or sorry, that you can choose whatever you want there basically.
Okay.
For username. For things, for resources in particular, like buckets, they have to be unique across the data center.
Because they map to URLs, don't they?
Yeah, they map to URLs. And Michael test is not taken. So you can define lots of things here. You can do version management, so it actually keeps different versions of your files when you upload them. You can do logging, so you can see who's accessing these files and when. You can also do encryption at rest if you want to do, and you could do a CloudWatch, which is like their monitoring service. You can see what's going on. If you have data in there, like company data, you want to see who's accessing what. That's a good way to go. And also, versions in case you need to backtrack certain things. Permissions here. By default, it's not publicly available, but you can make your bucket publicly available. Like the public files I have there, that one is publicly available because it's just publicly hosted content for the website. And that's it. Create the bucket, and it's right there. So you can create folders in here. You can specify encryption on the folder itself if you need to, and you can also just start uploading content. And you can upload as much as you want. It grows. It's pretty amazing. All you got to do is
The encryption on the folder, that keeps it encrypted on their hard drive backend, and then anytime you remount it, you have to put in the key to unlock it?
no. So you don't have to worry about that. It's encryption at rest, but
It's just no rest of the servers on the hard drives encrypted, but the interface will always be available.
Okay,
Yeah.
so it's not somewhere they're always going to be, okay.
yep. They do a pretty good job of that. Like their data centers are secured like room by room, floor by floor, on top of the entire campus. But if you do need that extra layer for compliance reasons, you can do encryption at rest. All right, what else? So S3 is kind of cool because you can actually host websites out of it. If you have like a static HTML website, you can map a URL to it, throw your website in S3 and host it, right? And at a penny per gig, you're pretty good. You can also do replications if you want to do that. You can replicate to like West Coast to East Coast if you have a need for that, or to Europe or to Asia. You can also do lifecycle, which basically says any data older than 90 days, just delete it from this bucket because I don't care about it. If you're doing log management or something like that. You can also migrate directly to Glacier, which is like their long-term storage where you pay super cheap. You can automatically say like, if my data is a year old, just move it to Glacier because I probably won't need it anytime soon. So that's pretty cool. All right, let's go see if we're, sorry.
There's no FTP or SSH access.
What's that?
There's no FTP access or SSH access to buckets. It's all API or web-based driven, as far as I'm aware.
So there is command line access, so I can show you that now if you'd like. Let's clear that. So I have my AWS, I can't see that. You see that? All right, so I have my AWS command line thing configured. If you want to do that, you could do like AWS. I'm going to specify profile. So AWS command line lets you specify n number of connections, and I have multiple connections. So for me, for my personal one, I specify it as me, so it knows which account to connect to. That's why I'm doing profile me. And then you can do things like S3 LS. And so here are all my buckets that we just saw in S3, the new one we created, my public one. And then if you want to see that one specifically, you could do S3. And then there was my folder food bar that we just created.
But you remember, in the proprietary software, you can't just mount that below the command line to access those like local file system.
You can use things like Fuse, what's the Fuse file system like thing, right? It uses SSHFS, or SHFS uses Fuse underneath. So you can do things like that to mount S3 as like a local file system itself. It works, I've done it. If you need that, you might want to look at like EFS, which is their...
I was going to say, why would S3 use over EFS besides some of the automated manager and automated controls or any benefits for S3 over EFS? The EFS gives you the raw access, but it doesn't have a lot of the kind of point-and-click automated and kind of controls that S3 does.
So that's the real reason why. If you have a cluster of servers running like the same web application, you use EFS to mount your data across each server. Therefore, it's it's a distributed file system and it's available to all the servers. If you're just trying to store content like files for company or personal files or whatever, S3 is a good way to go because you have that drag and drop functionality in the dashboard. It's accessible via URL, and you can get these other like management like features in there. Also, S3 has 9 levels of redundancy, whereas EFS, it has redundancy in it, but if you need replication, if you need failover to other zones, you have to build that into it, I think. or set it up to do that. Whereas in S3, unless all of Oregon got nuked, you would not lose your data in S3, right? The whole area would have to go down, and that's catastrophic in that case. That's never happened. Single zones have gone down, right? People make mistakes, power outages happen, but you will still have access because it's redundant. So anyway, if you want to do that, you can also do. If I go make a file on my desktop called foo. Actually, I'm going to make this an HTML file. You can basically do a copy if you're into command line. Oops. I misspelled Michael. Nobody told me. All right, so S3, or that file was copied over to S3. So if we go back here, we can go back to overview. And that file is right there. So click it, and then this is probably not public, but I can make it public. And there's my HTML file, foo, right? So pretty cool. Any other questions? Sorry, before I move on. No other questions?
What about the EC2? I'll jump to the, it might cover.
Okay. Let's go back to EC2. All right, so this node is ready. All right, so a couple of things. If you go to description, for example, you will see a ton of information here, pretty much everything to describe your VM. One thing Amazon does is it creates a public IP address and a public domain name, actually. So if you look at this really complicated address, and you go to a browser, it'll point directly to your VM. And because I didn't set up any kind of special security, my VM is exposed to the entire world. So, yay.
Isn't it just about the security group when you create the instance? Do you security group that was open to the world? Because usually the default security group is open to a certain global subnet.
Mine defaults open to the world. Yep, that's kind of intentional. I didn't want to mess with that for the purposes of this. But yeah, you could do a lot there to secure your actual application to make sure people only hit it on one port, and they, you got a load balancer in between or a web application firewall. It goes through there first and then to your server. Anyway, so here is Jenkins. It's a fresh install. All I have to do is select Jenkins, deploy, and it's there. And you can log into it. So the one thing about this one in particular is if we go to get system log. This is all the logs of that VM as it's booting. And the Jenkins one buries the username and password that it generated in the log here, right there. So my default user is user. You gotta read the docs. Some do it this way, some don't. So I know Jenkins does it this way. Oh, what happened? Copy. There we go. All right, so this is a fully functioning Jenkins server, and I didn't have to install any packages or do anything, right? I just picked the image. What's that?
What is Jenkins?
So Jenkins is a build system for your projects, right? It can do continuous integration, continuous deployment. So you can set up, most common use cases, you check code into Git, you got tests in there. Jenkins will pick up on the fact that you committed something. It'll check it out. It'll run automated tests against that. It'll do, if you have a container, it'll build a container, push it out to your registry server. In the case of like dev or test, it'll actually deploy it out to that environment for you. And it can do like notifications, emails. There's quite a bit that it can do. That's the most common use case for it. So anyway, I'm not gonna finish installing this thing, but it's there.
Quick things like on the IP address it gave you, is it just come out of a pool? Can you get yourself a couple statics, or with Amazon make it grab things like that? And if it comes out of the pool, can you have something where it sets the reverse DNS?
Yeah, so actually by default, this is dynamic DNS right here. If you shut this box down for maintenance or to resize it or whatever, you spin it back up, it'll likely get a new IP address. So you don't want to map your DNS directly to that address. What you want to do instead is go down here and you can get an elastic IP. I have one created for server running full stack to where this is my elastic IP that never changes, and it points directly back to this web server here, which has a different IP address, right? So what happens is if I shut this server down, elastic IP will, when this server comes back up, elastic IP will say, it's now pointing to this backend resource. It's like a reverse proxy, basically.
Are you doing it via CNAME or?
This is an A record
Okay.
for my DNS.
Okay. Yeah, my question is with regards to sticking an email server there and can't do it with a CNAME, because it breaks certain.
Yeah, you can do this. You can do elastic IP. You would just point it to this IP, which would never change. It's static, and in the back end, it just points to that resource. This is free as long as the resource is running. If your VM, what's that?
There's always a cost to it. That's
Yeah, if your VM is off, you pay for this, and it's pretty cheap, like pennies per hour or something like that. But yeah, as long as the VM is up, this is free. So you definitely want to do that if that's where you're going. There's a ton of things to do here. I'm not going to go into all of them, including load balancers. So I'm just going to go here, and then some quick operations. You can connect directly to it here if you want to do that for SSH. You can stop, terminate, reboot. You can create a snapshot of that VM. So if you're doing an update to the packages, you can create a snapshot. If it breaks, roll back to that snapshot, you're good to go. All right, you can change instance sizes, but typically it requires a shutdown. Monitoring, networking. I don't think I want to go into those too much. So I'm just going to stop. Yes, I want to stop. You can see that it's now stopping. Or if you right click, you can do the same thing. I'm going to terminate that VM. Saying warning, you will lose your data. Yes.
That's good to terminate DNS along with the instance.
Yep. Yep. All right. So we covered S3, we covered EC2. What else was there? Workspaces. All right. So I actually have a workspace running, and I had it set up ahead of time because these things take like 20 minutes to deploy. So workspaces, like I said, was a virtual desktop environment. I have one here running Amazon machine, Amazon Linux. Start workspace. It must automatically shut down. So there's also a client called Workspaces that I already downloaded. It's pretty simple to install. All you do is just log into Amazon and you can see your workspaces. Ah, damn it. This is an obnoxiously long password. Does anybody really want to see this? Does anybody here not use remote desktop?
It's remote desktop, right? That's pretty straightforward.
Okay. I don't want to like bore you with this whole login of like 50 character password. Basically that's what it does, and it works pretty well. Latency is super low. You can get a Linux and a Windows. You can get Windows Server, I think, and you can scale to like I can't remember how many hundreds of gigabytes in size for your desktop if you like need a workhorse desktop with an interface. It's not a bad way to go. And again, you only pay for the time that it's actually running, which is cool. So
When you log off, it's effectively shutting down the machine instance on the other side, or does it freeze it so you can have everything just laid out over your desktop the way you like and have projects open? Or?
So I think it does do a freeze. I'm not sure. I actually didn't tell it to shut down. So
Does it use EBS volumes or is one separate from the storage system?
I think it does EBS underneath. I don't know that you're entirely exposed to it. We can go see. Define a username here. So here's the things you can deploy. Amazon Linux 2. Power Pro, whatever that is, I don't know. Windows 7 with Office, and you can kind of see the sizes here. So we go Windows 10 with Office.
So if you fire, okay, so in firing up one of those Windows ones, they take care of the license key crap for you, they bill you?
They do. Yeah, so I mean, you pay for it.
Oh, okay, so it's significantly expensive for, well,
I can't remember the exact, we can go look up the rate.
well, give me a quick shot of it. The companies I work with were Mac and Linux. I got Windows running on VMware just to run QuickBooks. If I fired up the Windows 7 in the Amazon cloud, shove QuickBooks on it so we can do our accounting, am I going to be paying significantly more than the fact that I've already got a VM running on one of my servers?
All right, so let's go take a look. So here's Windows bundle options. Let's see, is there? You can bring your own license as well.
Yeah, I guess I'm wondering, renting a license, is it?
So it's this one right here. So it looks like for one CPU, 2 gig version, it's $725 per month.
Plus 22 cents an hour.
Yeah.
Okay.
And then if you go down to the bring your own license, it's 17 cents per hour. So 5 cents per hour for the license, effectively.
Okay.
So you pay for it, but I mean, you also don't have to do much, right? You just deploy it.
Yeah.
And it looks like there is an auto stop here. So it looks like it stops 1 hour after there's no activity. So you only pay for the time. You continue to pay for storage that you take up during that time, but you don't pay for the compute resource.
Yeah, and you're paying that monthly fee for them to store it for you, I presume.
Yeah, and if you got like a 100 gig hard drive, I mean, it's just $1 or $2 or something like that. I don't know.
Yeah, it'd be,
Or not even that.
If go on QuickBooks and all, it's like I think I've got about a 20 to 30 gigs image.
So the other thing you could do too is if you have a desktop environment like that, you can store your QuickBooks file on S3, and then when you spin up the desktop, connect to S3 to get that file.
Yeah, if I'm doing that, it's just I'm gonna do it locally because I'm already connecting to a local VM
Right.
to make the thing act as a server anyways.
Yeah. There's a ton of possibilities.
One of them is make something on an open source QuickBooks and break that last little thing keeping a lot of people on Windows.
Open source QuickBooks. That's
Quick for the note, it's also the Amazon Device Farm for like mobile developers. You can rent virtual desktop to license tablets, phones, and others to run and test your builds. So there's UPKs or iOS things, very cool. It's expensive. It's like $2 minimum a month, and those are thinking about $3,000 a month, depending on the end sessions. Just virtual device remote desktops, basically, and they'll do screenshots, video recording, and also system logs and all dashboards. So you can just upload it or a file address.
Is it all remote?
Yes. It's
Wow.
just like remote desktop. It's really, really cool.
That's pretty sweet. I've never actually used this,
They
so
have like 30 or 40 devices, so you can just test across different sizes and models and
that's pretty cool. That's nice. Yeah, I mean it's expensive, but if you're a service that does heavy app development, like maybe it's worth it than buying all these devices and constantly have to refresh every year when Apple releases a new device. All right, what else can we cover? So let's do. Does anybody really want to see a database instance launch? You want to see Aurora? Man, you're gonna make my bill expensive. All right, so this is the database dashboard, and you can kind of click here to see your instances. I actually have one already running. It's just an RDS instance. It's not Aurora specifically. The difference, it's all MySQL. The difference is RDS is just like a database running on a server, whereas Aurora is like this distributed thing. So you can see your metrics here. And if I'm going to connect to this really quick in a command line just to do a proof of concept. I think it's called test, and then, I don't know, I think it's test. It's a Roomba. It's possible the firewall might be blocking it, so it's not unusual. All right, let's go create an Aurora instance. All right, so when you go to create a database, you can select a few options. You can even do SQL Server. Aurora is really nice. 5.6 is the only one compatible with Aurora, though. And so here's kind of what you get with it, right? You get high throughput. It's auto scales. The auto scale part is kind of the magic behind it, because if your traffic starts peaking to the database, it literally automatically just adds CPUs and RAM. You don't choose the RAM or CPU; they are concurrent. They're tied together. I think it's like you can go to quarter CPU increments, and I think it's like a half gig with that or something like that. You get 6-way replication across 3 availability zones and 15 read replicas, and automatic monitoring with it. So
So in the different versions that you didn't have on the separate page, I presume it's making Aurora talk the tweaky differences between the databases, like Postgres has arrays on individual columns or something where MySQL doesn't. So if you selected Postgres, it's emulating that into Aurora.
it can still do. Aurora is just a wrapper around that service.
Yeah.
The difference is if you do 5.6, you can go serverless. So typically when you launch a database instance, you still have to say launch a database or a VM of this size, right? Like it's like the EC2 instance size you saw. You do something similar.
Okay, that's not the question I'm asking. Like if up top, if you selected like Postgres, is that it would make it. It wouldn't really be Postgres. It would be Postgres compatible talking to an Aurora database.
No, Aurora is not Postgres.
No.
Oh, okay. So you are okay. So you completely different engine. Okay.
Yeah. So Aurora is an option, just like Postgres is.
Got it.
And Aurora is.
I thought those were all backed by Aurora.
No. These are all like you can just launch independent databases of Postgres or type Oracle.
Okay,
Or,
so in each one of them, that is that natively that particular database.
yep.
Okay, so the Oracle one's going to probably cost you like a Windows 7 license.
Yeah. Yeah. Aurora itself runs MySQL and Postgres in the back end, so it's a little confusing, but it's a wrapper for that service they provide.
Okay.
So I'm going to go 5.6 because that is a serverless one, which means it can auto scale. And you got to specify serverless. If you don't do that, you got to go in here and select a size, which basically means what kind of resource do you want.
Yeah, so that will not scale with Index automatically because we need general Aurora connectivity and benefits. It seems like it kind of scales no matter what option you choose, but with the non-serverless version, it seems like it's a lot of self-management.
Yeah. Yeah, it will not automatically scale at that point. You can still scale it, but you have to I think you actually have to shut it down to scale it. There might be a way to.
Storage, but not the resources.
What's that?
I think it scales the storage, not the resources.
Yeah, the storage scales for sure. But the resource itself you'd have to manually do, or set up auto scaling to spin up another instance or whatever. But yeah, serverless will just automatically scale it. Username. I need a name, so all right, so this is where you define the minimum amount of resources. So the minimum you can do is basically 2 CPU and 4 gigs, and then the maximum. It'll still automatically scale, but this is basically specifying a threshold for yourself so you don't get a surprise bill. We can just leave it as is, define your security groups. I think that's going to not make it publicly available. You can define backup periods. So Aurora offers point-in-time snapshots, basically saying something went wrong today, I want to restore back to yesterday. You click yesterday's snapshot, you say restore, and it just restores the entire database to yesterday's snapshot.
Is that function going to be transaction logs, or that's separate entirely?
I don't know how it does it, but basically restores the entire thing somehow. The way it does it underneath, I'm not exactly sure. You can just go up 35 days back with these point-in-time snapshots. It automatically backs up to S3 as well. All right, so that is creating itself, and then at any point in time you can see the amount of capacity units it's using. So if you have no connection to it, it'll say 0, and then you will not get billed at all when it's not in use, aside from the disk space usage. It's kind of nice. You can use it for like,
Serverless mode.
what's that?
You only have built on non-use serverless.
Yeah. Yeah. It's still creating itself. This might take a little bit of time. Yeah, I can't even really do much to it until it's created.
Do you know what there's a see if it is a safe when the connection occurs? We haven't seen a server, HTTP server that makes a, a Python or PHP connection to that makes. Would it be milliseconds? Would it be second delay? Because I'm assuming we have while it's trying to.
Yeah, so there is a delay. It's not an instant start. It's not a cold start either, but I've seen it take anywhere from like 5 seconds to 30 seconds.
Okay, that's not. So would you recommend kind of like a contract view or limit that just to keep it active? Like a minimum threshold is always just never on.
So you can also set it to just not go to sleep.
Oh.
You can specify that threshold to say go to sleep in 5 minutes or go to sleep 2 hours or just never go to sleep. That's completely up to you. If you're running this for like dev or test, you can let it go to sleep pretty safely because 15 seconds, 30 seconds, not a big deal. In production, you probably don't want this. You probably won't use this for dev or test anyway because it's kind of fancy for that. But maybe you would use it for system like financial data you want to process at night or something like that. You can spin up EC2 instances that connect to Aurora between the hours of 12 and 6 and process a bunch of data. And then when they're done processing, the database will just go to sleep and not be used anymore. You won't get billed for it anymore. So there's a use case there too. Kind of just depends on what you need. All right, so it's actually available now. So we can do things like we can set capacity here. We can modify it. Modify the cluster. So here you can say pause in 5 minutes and so many seconds after no activity. You can go down to this, looks like you can do seconds. Oh, I guess you could do 5 minutes. So 5 is the smallest number you can do, or you can just take it off completely. All right. Do you want me to connect to it? Okay. All right. Otherwise, it's just a database. It's not actually one database. It's an instance. You can create multiple databases in there. So, what's that? Yep. And I think by default, it's not exposed to the outside world. Only Amazon resources. So, and you can further tighten it down if you need to. And you can connect to it from whatever you want. Yep. And it just works. It's kind of cool. Regular databases that you set up, they're not fancy Aurora, it's just a single database. You can also do things like configure replication to different zones, to different regions and different zones if you need to as well for redundancy or failovers. You can set up read replicas if you have a site that's read heavy, stuff like that. All right, what else? What time is it? 8? Oh wow, time flies. So I'm not gonna do a Lambda demo. But here's a basic example where you can just throw some code in there, and then when it's executed, it actually does something. So in this case, this one just prints hello world. doesn't do anything fancy, but you can tell to do things like process data, connect to a database, do some sort of queries. If you need to run a report, email it to somebody, you can trigger it that way. It's kind of a nice way to go. So here's an.
The call into Lambda is an API call from some server you have running within the Amazon boundaries.
Yeah, you can expose the API there where you can trigger it with that.
Can you hang a Lambda function on a port waiting for an incoming connection, or is that not exactly what Lambda could be used for?
I don't think Lambda can listen for incoming connection, but there are ways to get it to respond to events like this right here.
And the other thing is this Lambda that fires up, so if something else responded to an incoming connection, transferred it through to the call to Lambda, could Lambda sit there and have a dialogue with another server, waiting for more data, etc.?
It can respond back, but it's meant to be stateless by nature. And there is a cap to execution. I think like the most you could do is 4 minutes.
Okay.
So if you're
Well, yeah, okay, well, an execution of 4 minutes for my interest, yeah, would work. I can see that. I have an interest in mind where, it's going to sit there and have a dialogue chat with another server calling in. And then,
It could do that.
3 minutes or less.
Yeah, I could do that. The more common model would be to just execute another Lambda function on a return call.
Mhm.
So you make another call to another Lambda function for that other chat you have to have, if that makes sense, I guess.
Yeah, no, mine would be talking SMTP, it could be stateless between a connection, but during the connection, the state would have to be maintained.
Oh, okay, yeah, they could do that. And you could define like memory, like resource, you could say I need 128 megs all the way up to like 500 megs per call.
Yeah.
You can do stuff like that too. All right. So I'm not going to do a demo of this, but it's there. What else did I talk about? Beanstalk? All right, so this is the one that lets you basically deploy a web application just by uploading some code. So this one I can do real quick. So here you specify a name, you specify the platform you're running on, and in my case it'll be just a PHP app. I'm going to upload my own code. Let's say upload, choose a file. I have one here somewhere. Desktop, sample.php.zip. So this just outputs hello world and the time or something like that. You go create, and then it'll create that environment for you, and then deploy it. So it does need to be a zip file that you upload to it. You can't just do a single file. If you have a single file, still zip it up. You can still connect to other resources here. You can mount drives if you need to. There's documentation how to basically execute a task to do that. Let me see. Yeah. Yeah, so there's a way you can connect to Git repos to do continuous deployment that way. It's actually not, you can't really configure it with the dashboard. There's another way to do it. I think it's just command line based, but you can do it. The other thing too is if you're using this for a test environment, there's a command line tool. It's not the AWS one. There's one called, I think it's Elastic Beanstalk or EB, and you can say EB dev deploy or something like that, and it'll take your code as it is in the terminal and just deploy it out to a Beanstalk environment you have configured. So that's another way to do it too. Kind of quick, but yes, it can be done. So this also basically just auto scales for you. Go back to the environment, it's still spinning up. It'll give us a URL endpoint we could just hit to go see that web page. So took a few minutes. Is there anything else that I didn't cover that I talked about? I don't think so. So they do have a lot of other tools. If you want to run a Git server, there is I think code commit is the one. You can get a Git instance there. You can push your stuff out to it if you want. It's virtually free. If you have a build Docker images, you can create a registry out there to deploy. Yeah, create a repo. This is your Git stuff. You know, if you want your own. If you need help migrating an existing site over to AWS, they have a migration hub, which kind of shows you you connect your existing resources and it shows you the process and also the state of things. They have a service called X-Ray, which helps analyze your code, both real time and I think statically as well, and it tries to find vulnerabilities and areas of improvement. I've never used it, but that's supposedly what it does. They have deployment and build pipelines as well. I've never used any of those either. They have a simple email service where if you have a VM and you need to send emails, you connect to their simple email service here.
Just send mails on option things.
This is what you would connect SendMail to, yeah, or SMTP.
So what do you think you can do with the mail function? Do the default installations on Amazon and AI images include this, or do they use something else?
I don't know if the AMI images include a connection to this by default. You may have to still configure it in SMTP configurations. Also, you can't just send emails straight out of the box. You have a sandbox environment by default, so you have to like request approval to send emails, so you're not just spamming a bunch of people like a bot. And that could take 24 hours to get approval to actually send emails. They also have a service called SNS, Simple Notification Service. This is one I use often for notifications to the backend for myself. You can basically create a channel and you can subscribe to that channel, and that channel can publish text messages, emails, I think Slack notifications, and a bunch of different stuff. And so basically, if you have an event that happened in the backend, you can say AWS SNS notify to this channel. Here's my message, here's my subject. It'll basically publish to this, and then whoever subscribed to that channel will get notification in that form.
So how do PHP environment triggers? Is there a function that you're given access to, or how would you
So there might be a PHP library to do this natively, or you can just do an exec call to SNS. Yeah. So it's a nice way if you need to do basically back-end notifications for your team or for yourself to say, you know, something hit the fan. What's that? I don't know. They might. I don't know about that one. But yeah, you can do emails and text. So let's see if this environment's up, and then we can probably call it good. All right. The site is up. So everything looks like it's working. Shows you health check, so you got your actual configuration here. You can see the instance type that it's currently using, the software that's running, the security that's got, all of that. You can go down to logs to actually see the actual logs. You have to, request them. Health monitoring. How many resources it's using, alarms, events, all that kind of good stuff. You can actually see everything that's been going on in the system. And then, where's my actual link here? I did upload. Oops. Oh, here it is. Right in front of me. Ah, forbidden. So I actually called this thing sample, not index. So once I click sample.php, I see my little hello world. So if I refresh it, it refreshes the time because I'm putting it. not controlled because of htaccess necessarily, right? Nginx could do the same thing, but Nginx does not respect htaccess files. I don't know if htaccess actually works on Beanstalk. I'm not sure what it's doing. Yeah. For Apache, that works. I don't know if they're using Apache here or not, or if they're doing their own thing, or they're using Nginx. So I'm not sure about htaccess. But it does respect the typical directory hierarchy, right? So I didn't have an index.php, I had a sample.php, so listing the directory is forbidden until I go to a sample. So again, it's an obnoxious URL that they created. But yeah, so if I had a full application here, whether it was Node or Ruby, I could just deploy it and host it, and it works. All right. You can also do like versions and continuous deployments with this, but anyway, there's a ton here to talk about, and I don't know really half of it, so I think with that we can end. Thank you for your time. I know I went probably a little bit over, but if anybody has any specific questions.
I do two questions. One real quick is, have you dealt with the shared IPs, Alaska IP on all egress traffic among a group of EC2 instances?
Are they low balanced?
No. Yes, there will be an auto-configured load balancer, an auto-set load balancer, and you want to share some egress IP address, like this thing.
You want to share the IP address of the actual VM?
Essentially, yes, all egress traffic is facility. So you can connect to them through the load balancer and distribute connections, but all outgoing traffic goes to a single external IP address from all their instances. Have you?
So they by default go through a single external IP address, which is your load balancer. All egress by default goes through load balancer.
I'm referring to connections initiated within the VM instances. So the VM wants to connect outward to an external resource. Does it also do load balancer?
No, unless you define that.
Yeah, because usually they go from the HTTP assigned public IP address.
So a VM can reach, typically the setup is ingress is restricted through the load balancer, right? And if traffic comes through load balancer, it'll respond accordingly, because that's just a connection from the load balancer. If the VM itself is going out to grab a file, it'll go by itself through the internet gateway.
Yes, I'm thinking the internet gateway can configure a single egress Alaska IP. Have you worked with that before?
It should just go back out as that same IP that it requests.
No, this would,
No, let's say you have 20 instances running, and they're all making independent calls to a Stripe API.
Oh, you all want them all on the same IP.
Whitelist the single IP address for your machines, for your servers. That's essentially what I'm looking for.
You-
There's an egress mechanism I read about, I haven't seen it in use.
I don't know if there's a service like that, but you could set up a proxy server.
Yeah, it's essentially a proxy server. It's a built-in. I just haven't used it.
There might be a service. I would not surprise me. I have a service for everything at this point. But yeah, essentially, if they don't, you would just set up a proxy server and proxy all your traffic outbound that way. And then, yeah, it would respond with the same IP address. You said you had two questions.
Okay, the second question would be shared configuration amongst EC2 instances that are dynamically spun up and down on Apache, for example. My thoughts were doing a symlink on the HTTP.conf file on the instance images, and then mapping that essentially to EFS share or EFS that volume. Because as you change and dynamically add different virtual hosts and machines come up and down, you want them to be maintain a synchronicity among the actual virtual hosts that they expect. So you have, 5 to 20 VMs coming up and down as traffic leaves them, they should all respond to the same HTTP directives. And any recommendations on that approach?
So you have 3 VMs all running Apache,
Yes.
and they all have the same virtual host configuration?
Yes. And then if you want to add virtual hosts, or and this is obviously going to be 3 to 20 minutes from now, and you want to add to a virtual host, you all want them all to respond to the specs of those, no matter what they change. How would you impose changes in a dynamic fashion? This network goes using a similar onto an EFS volume, so they all are reading from the EFS at all times. So as it's been up and down, we'll just
So that is one approach. You can continue doing that, because then it's reading it from a single file. You could also use like Chef or Puppet or Ansible to do configuration management. So you can deploy, you can configure your virtual host in your Chef configuration or your Puppet or Ansible, whatever you use. And you can say deploy, and it'll actually go through and deploy to each of these VMs by itself, and it knows how to write that virtual host to Apache. That's another way to do it. So it also depends on what you're load balancing, because you could also maybe remove Apache from those nodes, have a single Apache instance that reverse proxies to like backend PHP nodes to do it that way, in which case you only have one server managing, right? You can load balance a different way, basically. Yeah. All right. Is everybody thoroughly ready for bed now? Cool. All right. Yeah. If you guys want to go to the tour, like I said, please give me your information now or at some point.
What information do we need?
That's what those stickies right there are for, actually. No, first name, last name, as it appears on your ID, obviously. Date of birth and your last four of your social security. Make sure it matches your ID, please. Not an alias that you have. Yeah, and put your email down there for me as well. That way if I have problems I can contact, or your phone number, I can call you and contact you if there's any problems. Otherwise, Discovery Hall at P&L, December 5th at 4 p.m. And then, so any votes as to where we should go for drinks and dinner? I was going to suggest Shogun. It's right next to P&L. It's like teriyaki, sushi, and they got pretty decent beer. Is that one vote for Shogun? Yeah? Okay, well, unless anybody else votes or has other suggestions, we'll do Shogun afterwards because it's right next to it. And it's a pretty good option. So, all right, cool. Thank you guys. Have a good one.